0. It says determine the roots of each quadratic equation and verify your solution. So determining the roots means finds the x-intercepts, if you were looking at a graph, or here, what it really means with an equation is it means find the x values that make the left side of the equation equal to the right side of the equation. So that's when they say verify your solutions, that's how you verify it, is you would plug it back into the original equation, and we'll practice that too. Okay, so we go through our steps. The order is good. There's no greatest common factor here, so we don't have to worry about that. And then binomial, trinomial, or 4 terms, it's a trinomial. So I need to look at the factors. I'm just going to write this one back out. I want to look at the factors of, and I can set it equal to 0, that's fine, of 1 times 9, and I'm going to get 9. Okay, and my factors are 1 and 9, 3 and 3. Again, if you're fast at that and you don't think, hey, I don't need to make the whole list, that's fine. If you know just which ones they are, you don't have to make the whole list. Okay, and I want the same signs because I had a plus 9 here. Which ones add together to get 6 would be my 3's, okay, and I want them to both be positive. Okay, this is an easy factoring because I just have a 1 here, which means my factors would be x at the beginning of both, and then I just have a plus 3 and a plus 3 here, but it is still equal to 0. Okay, now I have 2 factors, x plus 3 and x plus 3. In order for x plus 3 times x plus 3 to equal 0, at least one of these has to be 0. Now technically they're the same, so even if I were to solve this, so let's pretend that this was the one that was equal to 0. I would subtract my 3 over to the other side, and I get that x is equal to negative 3. I'm going to get the same thing on this one. I'm going to get that x is equal to negative 3. Okay? So all that means is instead of this one having 2 x-intercepts, how many does it have? It just has 1, right? And what kind of a quadratic or parabola only has 1 x-intercept? Where is that x-intercept on the graph? What part of the graph does it hit? The vertex, right? So that means your vertex is right on the x-intercept. That's the only way that you can get just 1 x-intercept. Okay, for verification. So if you wanted to verify this, you start with your original equation. Okay, and that's really important. So if your original equation was not equal to 0, let's say it was equal to 2 or something like that, you start with that one. Okay, you do not rearrange it first when you verify. So this one would be x squared plus 6x plus 9 equals 0. Okay, and when we verify, you need to make sure that you're not switching from left side to right side. You're not adding or subtracting or multiplying and dividing things over from one side to the other. We want to prove now that the left side equals the right side for every time that x is equal to negative 3. So here I put my negative 3 in with a squared. That's my x, plus 6 times my negative 3 plus 9. So every time I had an x, I put in a negative 3. Negative 3 squared, be careful when you throw out your calculator. If you throw it in like this, you're going to get the wrong answer. You'll get that. If you throw it in like this, you'll get the right answer. You will get this. So our entire x is getting times by itself, and our x was negative 3. So negative 3 times negative 3, this is going to be 9. This part will be negative 18, and this part will be plus 9 still. It ends up being 0. This side there's nothing to do, so I usually just carry it down. And then you need to be saying that the left side equals the right side. It's okay if you use abbreviations like that, LS, RS, but you have to say that. And when you have a diploma in grade 12, and you're asked to verify, you do have to say that at the end. Okay, so check mark, that answer does work. Okay, this is also the part where you could go on your calculator and you could figure out what the x-intercepts were by going second trace 0, and you'd see that there's only one of those.